Hello! Today we are continuing our study of chemical formulas and learning how to compose formulas for Category 1 and Category 2 ionic compounds that are formed by polyatomic ions. However, in this specific case, I would like to provide you with an explanation of how the name is formed, taking into account the oxidation number and considering all relevant factors. So let's remind ourselves that we have connections in which there can be, for instance, an ion 1 as an illustrative example. This is not a polyatomic, it is a binary compound of sulfur. For example, it can have a charge of 2. In that situation, we provide it with the subsequent designation. And the suffix ending will always be IDE in this case. This suffix is always present in all connections where the elements have only one element, which is in the second place. He always has a negative charge, and then everyone will have the suffix ending IDE. Here is an additional example. Chlorine with a negative charge. Therefore, there will be chloride present in this particular case. And so it will be in all cases where the elements consist of 2 elements. But those will be binary compounds, not polyatomic ones. Well, let's give some more examples and learn how to compose such formulas. So, let it be a combination of sodium and sulfur. All right, sodium has a positive charge, sulfur has a negative charge. So let's use the cross rule. The name is going to be sodium sulfide, and the suffix ending is going to be like that, or it could be sodium chloride, depending on the situation and context, respectively. Now let's move on to the polyatomic ones. Let's say if it's SO3 with a charge of 2. If there's an element in the ion that's in an intermediate oxidation state, let's learn how to do this. Let's calculate the oxidation state, which is the oxidation number. Oxygen is -2, so for sulfur, let's calculate it using the equation X. 6 equals -2. Then in this case, X will be equal to +4. For sulfur, +4 is not the highest level of acidity, so in this case, the suffix ending will be like this. And the suffix will change. Pay attention to ITE. Here's an ID because there was only one sulfur, but here there are 3 elements. Oxygen is present. The element isn't highly oxidized. Let's give another example to illustrate. Let's assume that this will be a connection involving the element potassium in our discussion. So potassium has a plus and we have 2 minuses for SO3, and accordingly potassium 2SO3. The designated name for the substance will be potassium sulfate, as determined by the relevant authorities in scientific classification. All right, cool. Now, can there be elements in other oxidation states? Certainly. So 4,2. We'll determine the oxidation state for this particular compound. It will be -2 here, and then it will be +6 here, gray. For gray +6, this is the highest degree of oxidation, so the name will have a different suffix. And he will possess the IT suffix, that is how it is. And then let us have it be calcium, for instance, at our place. Calcium possesses a positive 2+ charge, while SO4 carries a -2 charge, thus resulting in the compound being named calcium sulfate. Currently, at this point in time, when the elements are capable of having other intermediate positive oxidation states, for example, chlorine O with a negative charge, if we calculate the oxidation state here as -2, then for chlorine here in this case, it will be +1. The assigned name will include the prefix, resulting in the final name, hypo. So here's the deal. Check it out. We got the same suffix at, but now we got this new thing called prepex. Well, for instance, let us provide the formula of such a compound. Let it be a connection of this type. On A3, chlorine O plus, chlorine O minus. So the formula is correct. The name will be then. Go ahead, next up, chlorine has halogens like this ion. Chloro-2 with a charge, let's calculate the oxidation state in it. -2, then chlorine here has a +3 charge. Then the name of such a particle will be mentioned here. Chlorite. The suffix ending will be I. However, there will no longer be a prefix attached to it. Well, let's say like this connection here. Add chlorine to oxygen, subtract the formula, ensure it's correct, then the name will be like this. All right, let's move on. If chlorine has an oxidation state in another compound, chlorine has a negative charge of 3 particles. We calculate the oxidation state again, -2. Here chlorine has a positive charge of 5. So then it turns out the name will be like this. And the suffix ending becomes like this. For example, let's say we have a connection with magnesium, just to illustrate the point. So magnesium possesses a +2 charge and chlorine possesses a -3 charge. We utilize parentheses and implement the cross rule. These are the steps of the cross rule. Initially, write the name of the first element, chlorine, then write the name of the second element, magnesium. Now chlorine forms a compound with a charge of 4-. This compound is formed by the combination of magnesium and chlorine, which have charges of +2 and -3, respectively. Calculate oxidation state here, -2 + 7. For chlorine, it is the highest degree of oxidation. And at that moment, we will assign it the name perchloride, as we have previously discussed and unanimously decided upon. Hey, check it out. There's a prefix per and a suffix ad popping up. Well, let's assume for the sake of argument that this is an aluminum connection. In this scenario, we have -aluminum 3+, with brackets making another appearance. And behind these brackets, the name will be identical to what we have described. That is precisely how the name will be in this particular case, without any deviations or variations. Hey, pay attention, that's when you say hello. But we have particles and more complex polyatomic ones. To provide an example, let's consider HPO4 with a charge of -2 as a specific illustration. All right, let's do the mathematics again. Let's subtract 2 here plus 1. Phosphorus here is +5, but then hydrogen appeared, and that's when the name of such a particle will be. And pay attention, because there is hydrogen present, the prefix hydro is used. All right, and in the scenario where the particle is denoted by the chemical formula H2PO4, it would possess a negative charge, resulting in a charge of -2 + 1 + 5 for this particular particle. Consequently, to indicate this, the prefix tak is appended to the name of the particle, as can be observed. It is worth noting that the names of particles can become considerably more complex and intricate, as exemplified in this instance. I hope it's become clearer how they work in such names and how they work with suffixes. But in reality, this is of course a pretty tough topic, but for today that's all we have. Goodbye.